Hi, my name is Emily Ireland, and this is my Lab 4 for Physics 2. So the purpose of this experiment was to let a magnet fall through a tube of aluminum foil. For the computer simulation, I used GlowScript to model the same experiment, and I compared the results. In the real experiment, the magnet fell out of the tube at 0.987 seconds. In the computed experiment, the magnet fell out of the tube at 0.547 seconds. So the important concepts for this lab were Faraday's law, which is a changing magnetic field in a loop creates voltage proportional to the change in magnetic flux to oppose it. And this formula you can see on the left, where EMF equals negative N times delta phi over delta T. Then we have the Biot-Savart law, which states that a steady current produces a magnetic field. This formula is on the bottom left. Then we have Ohm's law, which states that EMF equals induced current, which is the negative change in magnetic flux. Then we have the gravitational force, which is F equals mg. And Newton's third law, which states that every action has an equal and opposite reaction. For this experiment, the system is the magnet, and the surroundings are the tube and the earth. So the procedure. First, I measured the mass of the magnet, then I measured the height, width, and thickness of the aluminum in the tube. Then I dropped the magnet through the tube 5 times and recorded the time it takes for the magnet to reach the bottom. Then I took the average of those times, which I put at the beginning. Then I used the data collected to create a GlowScript computational model, and I compared the results. My data, the tube height was 18 centimeters, the width of the foil was 0.06 centimeters, and the radius of the tube was 2.6 centimeters. These are the results of the computational model. The graph is velocity versus time. The time in the tube was 0.5 seconds, which was different than the experimental result, but that's probably because of the sources of error that occurred. And as you can see, there's a larger slope downwards, then it reaches a plateau and then goes downward again when it finally falls out of the tube. So the important pieces of code I used to model this were basically the initial conditions. So I put in all my data that I had collected, including the mass of the magnet, which was 0.03 kilograms, and the mu that I calculated in lab 2 of 5.295. So, and then additionally I used the formulas discussed earlier to calculate the magnetic field, flux, and force of the magnet, basically by breaking down the equations step by step in lines of code. And then possible sources of error. The biggest source of error was probably issues with the stopwatch for the actual experiment. I had a shorter tube of aluminum foil, which meant the magnet went through it faster, and so it was very difficult to actually calculate the amount of time it was in the tube because I didn't have anyone to help, so I had to do it with one hand. So yeah, and then another source of error was measurement mistakes. The equipment I used could have been not accurate and I could have messed up somewhere, and then also air resistance plays a factor in the tube for the magnet falling. So basically, the idea of the lab is that magnetic force and gravity are fighting each other, and that's the magnetic force causes the plateau. So, what if the resistivity of the conductor were reduced as close as possible to 0? How would the dynamics of the falling magnet change? So resistivity is directly proportional to resistance, so if nearly 0 resistivity means nearly 0 resistance. And then resistance is inversely proportional to current, meaning current would be a lot larger if resistance is near 0. And current is proportional to magnetic force, so more force means the magnet would fall slower, because it would be more force that is acting against the force of gravity. And then what if holes or slots were cut into the tube? How would this affect the ring currents in your model? This would disrupt the rings of the aluminum tube, which would decrease the induced current. Decreasing the induced current reduces the magnetic force. This would make the magnet fall the magnet fall faster because the magnetic force is the force disrupting the force of gravity. And that's all. Thank you.